Hello everyone, welcome back. Here is vanAmsen. Today we are diving into exciting coding problem called minimum right shift to sort the array. And this problem is perfect for those preparing for coding interview or anyone who just love a good algorithmic challenge. So I will be solving this problem in Go, but don't worry, I got Python, Rust, C++ implementation in description below. So make sure to stick around till the end. And yeah, so let's first go over the problem statement to understand what we are dealing with. So you are given, or we are given, a zero index array containing a distinct positive integer, and our task is to find the minimum number of right shifts needed to sort the array. A right shift is defined as shifting the element at index I to index I plus 1 modulo n, where n is length of the array. So yeah, better let's type it. So shifting I to I plus 1 modulo n, and n is length of the array. And if there is no possibility to sort the array using the right shift, we should output -1. Okay, so let's take a quick example to make things clear. So given 3, 4, 5, 1, 2, and after the first right shift, it becomes 2, 3, 4, 5, 1. So it was first, 3, 4, 5, 1, 2, and then it become 2, 3, 4, 5, 1, and after the second right shift, it become 1, 2, 3, 4, 5. So the answer should be here 2, because we need only 2 right shifts. So the approach to solve this problem can be broken down into 3 key steps. So first, finding the pivot point. So we look for the point around which the array is rotated. So this is where an element is greater than its next element, and check for multiple pivot points. So if we find more than one such point, it means the array cannot be sorted with right shift. So also calculate right shifts. So if there is only one pivot point, the number of right shifts required is the distance from that point to end of the array. So let's now dive into live coding part. So I will be using Go for this one. So let's start implementing. And len nums and pivot count will be 0, and pivot index will be -1. So now what we do, step 1, finding the pivot point. So for I less than n, increment, we iterate, and if greater than num at I modulo n, pivot count plus plus, and pivot index equal I. And now step 2, check for multiple pivot points. So if pivot count greater than 1, return -1. So step 3, calculate right shift. So if pivot count equal 1, return n minus pivot index plus 1. And if the array is already sorted, then return 0. As simple as this, we can run it to verify it's working, and we got output 2 for example number 1. Yep, all good. So perfect. So now everything's work perfect. So we can also submit it for unseen test cases to verify how fast it is. So as you can see, our implementation took just 0 millisecond, beating 100% with respect to runtime, and also 100 with respect to memory. I also previously implemented this in Python, and as you can see, it's quite different with same logic. So Python took 51 milliseconds and Go really fast, just 0, so probably less than 1 millisecond at it was rounded. So there we go. The function works perfectly, giving us correct number of minimum write shifts needed to sort the array. And I hope you found this coding problem and its solution interesting. And if you did, please give this video a thumbs up and let me know in the comment what you would like to see next. And of course, subscribe if you haven't yet to stay tuned for more awesome coding content, machine learning, tech, and much more. And for those interested in other implementation, I will provide a link in the description. And until next time, keep practicing, stay motivated, and happy coding.